Probability. That is the topic for this session. We all would be aware that probability is defined in a very simple way. It's a possibility, a chance happening, and that chance is measured as the number of favorable ways divided by the total number of ways. Since the number of ways have to be non-negative, we know that probability will always be non-negative. And since we also know that the number of favorable ways can never be more than the total number of ways, the probability has to lie from 0 to 1. A probability of 1 denotes a certain event, it has to happen. A probability of 0 denotes an impossible event. There are 0 ways in which the event can happen as such, right? Now, almost every question that we learned in permutation combination can also be asked in a probability language, though usually it is not. Example, we did question where we asked in how many ways can a 4-digit number, even number, be formed given certain digits. It could be rephrased as what is the probability that a 4-digit number formed is even. Or when arranging people, we found we learned how to find number of ways in which 3 specific objects are together. Change it to a probability language, find the probability that the 3 specific objects are together. So whatever we found will come in the numerator and total number of ways in the denominator. Each and every question could be formed. In committees, we find the number of ways in which a committee can be formed such that there is at least one woman. It could also be asked as what is the probability that the committee formed has at least one woman. We would not be doing those questions out over here because once you use this formula, rest of it is just a question of counting the number of ways using permutation combination logic. So here we would be handling another types of questions which are purely based in probability realm and not in permutation combination. The most common question is that involving tossing coins and rolling dice. We will come to tossing coins later. First, let's do questions rolling a dice. So when one die is rolled, I could get the outcome as 1 or 2 or 3, 4, 5 or 6. If it is a fair die, which we have to assume in each and every question unless otherwise stated, each of the outcomes will be equally likely. So the total probability is 1, has to be distributed among them equally. So the probability of each is going to be 1 by 6, or the other way to think about it, total ways are 6 ways. The number of ways you can get a 3 is just 1. So the probability is 1 by 6 out way up. There's not much questions in rolling one dice. So most questions are based upon 2 die or dice, 2 die, the plural form, are rolled together. And then questions would be either on the numbers turned, the sum of the numbers turned, or the product, or it could be many different formats. So let's see the total possible ways in which when 2 dice are rolled. It would be reasonable to assume that we are aware of this as well, as first die has 6 possibilities, the second one has 6 possibilities, so together they have 6 into 6, 36 possibilities. However, it would always be advantageous to remember this grid. One of the dice could turn up a 1 and the other one also 1, or it could be 1 2 or 1 3, 1 4, 1 5 or a 1 6. So 1 is on the first dice and the second dice could have 1 2 3 4 5 6. Similarly, we could have a 2 1, 2 2 and so on right up till 2 6, and the row wise it would have a 3 1 or a 4 1, 5 1 and a 6 1. So this is the right up till 6 6. So this is a grid of 6 by 6. The reason I wrote this down here is to highlight one point. The outcome 1 2 is counted differently as well as 2 1 is counted differently. That gives us 36. So remember the fact that 1 2 is different from a 2 1. Whereas if you look at a 1 1, it appears only once in the grid. Similarly, a 2, 2 appears only once in the grid. Keep this point in mind while we'll solve questions. The standard questions are about the sum of the two numbers turned. So let's find the different possible sum. The minimum that could turn up is the minimum on each dice. So on the first dice there's a 1, on the second there's a 1. The minimum sum that could turn up is 2. And then I could also have a sum of 3 or 4, 5, 6, 7, 8, 9, 10, 11, 12. Could it go on infinitely? Not really. The maximum number on a dice is 6. So the maximum sum that could turn out to be is nothing but 12. What if I ask you, what is the probability that the sum turned is 10? Is it right to say that the total possible values for sum are 2 to 12, that are 11 possible values? 10 is one of them. So is it that this is going to be 1 out of 11 possible values? No, this would be wrong. What is wrong in this approach is these sums are not equally likely. For example, let's see how can we get. A 2 could be obtained only as the dice rolling up 1 and 1 each. So this is just one way. Whereas a 3 I could get as 1 and 2, and the other way is 2, 1. We know that both of them are counted differently in 36, so here also I need to count them differently. So I could get 2 ways in which a 3 comes in. So 3 is more likely than 2. There are more number of ways. So we couldn't say that this is 1 by 11th and this is 1 by 11th. If you look at it from the other extreme, again a 12 can be obtained only as a 6 and a 6. That is in one way. Whereas 11 could be obtained, since it's at the higher end, I'll start from the higher end of the spectrum. One dice rolls 6, the other one has to roll a 5, and then will decrease one of them, increase the other, and proceed. So the next one is going to be 5, 6, and it stops. You could not have a 4, 7 because 7 cannot be rolled. This is also 2 ways. So proceeding in the same way, if the question was requiring us a probability of finding 10, we would reach 10. You need not do the others, directly approach 10. How could, since 10 is at the higher end, start with I could have a 6, 4 or a 5, 5 or a 4, 6. So in how many ways are these? These are 3 different ways. So the required probabilities, 3 ways are acceptable out of a total of 36 ways. And this is going to be my answer, 1 by 12, the probability for 10. If the probability the question was asking you is the sum is greater than equal to 10, then I could even have a 10, even I could have 11 or a 12. So I would add all of them, which is 3, 4, 5 and 6 different ways. So the required probability now would be 6 by 36, 1 by 6 is the correct answer. So easy questions out over here, and it would help you, it would definitely help you to even remember this pattern here. If you notice, as I move from the extremes, the extreme 2 and 12 has only one way, 3 and 11 have 2 ways, 10 has 3 ways, would 4 also have 3 ways? Let's check it up. 1 and a 3, 2 and a 2, 3 and a 1. That's it, 3 ways. So as we move from the extremes towards the middle, the number of ways in which I can get the sum is increasing. So let's continue this, and this pattern goes linearly at least when 2 dice are rolled, not for later. So we would have 1 way, 2 ways, 3 ways, 4, 5 and 6. So does 7 have really 6 different ways? Let's see. First dice, just focusing on the first one. First one could have a 1, the next one could have a 6, or 2 and something, 3 and something, 4 and something, 5 and another thing. So how much would 5? 5 and 2 would make up a 7. Similarly, I could have a 6 and a 1. 1, 2, 3 and then 4, 5, 6. So is this 6 ways? 1, 2, 3, 4, 5, 6 ways. Right? Hope you get this pattern very clearly. Then there are numerous questions where we could frame anything that one of the number turned is a prime, the other is non-prime, which you could easily count from the grid. So I'm not continuing on the same point. Let's go to a different scenario.